Welcome back to the Explainer. Today, we're zeroing in on an absolute must-know, level 1 interview question in tech right now. What exactly is machine learning? Whether you're brushing up for a big job interview or you honestly just want to understand the technology that's completely shaping our world without drowning in jargon, you are in exactly the right place. We're going to break down the core concepts so you can walk away with an airtight, perfectly interview-ready answer. Here is our roadmap for today. First, the old way versus ML. Second, defining machine learning. Third, supervised learning. Fourth, unsupervised learning. And finally, number 5, reinforcement learning. All right, section 1, the old way versus ML, moving beyond manual rules. To truly appreciate what machine learning is, we kind of have to look at the outdated methods it's replacing, right? Starting with the absolute pain of traditional programming. Historically, if you wanted a computer system to do something, a human being literally had to sit down and explicitly write out every single rule. Imagine a system administrator typing out, if the CPU is greater than 90% and the response time is greater than 5 seconds, then raise an alert. Doing that for every single possible scenario? The sheer exhaustion of writing endless if-then statements is just completely unsustainable in modern IT. Contrast that with a machine learning approach. Instead of manually typing out every possible trigger, an ML system learns from thousands of past incidents. It automatically predicts which combinations of metrics will cause a massive P1 or priority 1 incident before it even happens. It's a total paradigm shift. Moving on to section 2, defining machine learning, the core concept. So when a hiring manager asks you to define machine learning in simple terms, here is your golden definition. Machine learning is a way of teaching computers or systems to learn from data and make decisions or predictions without being explicitly programmed for every scenario. Notice that phrase right at the very end, without being explicitly programmed. That is the key differentiator. We're stepping back from being the rule makers. Instead, we just feed thousands of examples to a computer system, and the system itself figures out the underlying pattern. You provide the data, and the system becomes the detective. Once you deliver that perfect definition, you should definitely brace yourself for the classic follow-up question. So, what are the 3 types of machine learning? Let's break these down categorically, starting with the most common one. Section 3, supervised learning, labeled data. Think of supervised learning as giving the model a cheat sheet. We give it labeled data, meaning we provide the input along with the correct answer. The model studies these pairings and then learns how to predict the correct answer for entirely new, unseen inputs. For example, imagine feeding a system a massive batch of past IT incidents that humans have already clearly labeled as either P1 or P2 severity. By studying those past examples, the model learns to predict the severity of brand new incidents the exact moment they occur. Oh, and if you really want to impress in an interview, you can casually cite specific algorithms used here like linear regression, decision trees, or random forest. Always sounds impressive. Next up is section 4, unsupervised learning. Hidden patterns. Now, let's see what happens when we take the training wheels off. No labels, no cheat sheet. This happens when we give the model data without any labels at all. There are 0 correct answers provided up front. Instead, the model has to do the heavy lifting to find the hidden patterns, all by itself. Imagine dumping a massive, completely unorganized log of IT incidents into the system. The model will automatically group similar incidents together based on their characteristics, without you ever telling it what the categories are. Behind the scenes, data scientists pull this off using techniques like k-means clustering or PCA, which stands for Principal Component Analysis. And finally, section 5, reinforcement learning, trial and error. This quote really hits the nail on the head. The model learns by trial and error, getting a reward for good actions and a penalty for bad ones. It is a highly unique behavioral style of learning. Honestly, it's a bit like training a puppy. You don't hand a dog a spreadsheet of labeled data to read. You put it in an environment, let it take actions, and then provide feedback in the form of a digital reward or a penalty, depending entirely on the outcome. And this perfectly illustrates its application across the tech world. A fantastic enterprise IT example is an auto remediation system. This is a system that literally learns which software fixes resolve incidents the fastest through continuous real-time trial and error. Beyond the IT help desk, this is exactly the type of machine learning being used right now in game AI to create challenging virtual opponents, in advanced robotics to teach machines how to walk or pick things up, and in the incredibly complex systems powering self-driving cars. They learn how to navigate the road by constantly adjusting based on those penalties and rewards. So the crucial point is bridging all of this interview theory directly into reality. Think about the massive IT problems facing companies today. Between supervised, unsupervised, and reinforcement learning, which type of learning is going to solve your next P1 incident? Will it be a supervised model predicting the crash based on past labeled data? Or perhaps a reinforcement model automatically applying the perfect fix through trial and error? Getting a grip on these three pillars doesn't just help you ace an interview. It fundamentally changes how you see the automated systems transforming our daily workflows. Thanks so much for joining me on this explainer, and hey, keep looking for those patterns.